So this is the Impulse Momentum Lab. What we'll be doing is launching this glider against a force sensor, which will measure the force of impact on the glider. We'll also be measuring the velocity of the glider before and after the impact, and apply the impulse momentum theorem to see if the impulse is equal to the change of the momentum. We will need to know the mass of the glider, which I've already recorded as 0.3164 kilograms. It's important that we start with a level track, so this is a level that we've set to 0 degrees. Move that out of the way. And we're going to have two runs, first with a soft bumper attached to the force sensor, and in the trial number 2 we'll use a stiffer bumper. The impulse momentum theorem should be valid in either case. So we're ready to go ahead and take data for the first case as a sample of the procedure. So let's go ahead and first zero out the force sensor, and then let's start the timer and launch the glider. Catch it before it impacts. There's a typical data record. What we'll need to do is to measure the initial velocity, which is depicted in the velocity panel up at the top. The initial velocity just before the impact occurred, the horizontal flat portion, and then the velocity just after the impact occurred, the second horizontal flat portion. In the second panel below, we have the force versus time, which we can analyze to measure the impulse of the force, which corresponds to the area under the force versus time curve over the time interval of the impact. So let's step through this to get a sample set of readings. In the velocity panel, I will click and select across a portion of the record just before the impact occurred, and measure the average velocity over that interval, which I can see here is minus 0.5417. I'll record this. Initial velocity, trial 1, minus 0.5417 meters per second. Then we'll measure just after the impact concluded, just after the graph gets flat again over a small portion, not too long because we don't want friction to have a chance to play a significant role. We'll now measure the average velocity over that small time interval, which is average velocity 0.5473, final velocity 0.5473. And the remaining thing we'll have to measure, or things, is down in the force panel. The graph will select over the region where the force was different from 0, approximately from here to here. And then, using the tools at the top of the application, we'll measure the integral or area under the force versus time graph. We're getting an answer of 0.3351. The impulse, positive 0.3351. In addition, we would like to record the average force over that interval. Without selecting anything new, we could simply go up under the statistics button tool at the top and select, and that will give us the value of the mean or average value of the force over the interval was 1.117 Newton seconds. That would give us 1.117 Newton seconds average force. For the time interval, which is also needed for the calculation, we can look down here in the lower left-hand corner for the selected delta t corresponding to the time interval we selected on the force graph, and I'm showing 0.30 seconds. Delta t equals to 0.30 seconds. This concludes the data taking for trial 1, corresponding to the soft spring. Over here we've got a copy of the set of data that we made earlier for the soft bumper and then for the stiff bumper. And let's report that data. You can use this for your analysis in your lab report. So the card mass, as I stated, was 0.3164 kilograms. We can keep things to 4 significant figures. For trial number 1 for the soft bumper, which I took earlier than the display, the initial velocity was minus 0.5354 meters per second. Final velocity positive 0.5125 meters per second. The impulse, or area under the force versus t graph, was 0.3355 Newton seconds. And the corresponding values for the average force over that interval, positive 1.117 newtons over a time interval of 0.29 seconds. We then replaced the soft bumper with the stiff bumper and re-ran another case, trial number 2. The initial velocity proved to be minus 0.6990 meters per second. Final velocity positive 0.6427 meters per second. The impulse was measured to be 0.4289 Newton seconds. The average force over the interval 0.2147 newtons. I forgot to put the N symbol. And delta T, the time interval of that collision, was 0.20 seconds. This concludes the data taking for the impulse momentum experiment.